This is Station 4, the Vogt Reel House. It's the oldest fire station in Lexington.
We brought you a pumpkin. Yeah.
Wow, fantastic. You brought us a pumpkin. Thank you very much, guys. Did you do this yourself?
Yeah. Yep.
This looks fantastic. This is great. Did you all use some kind of special paint up here on top? No, I think we can check that out inside. You guys want to come in?
Yeah.
Hey, but I have to warn you, first of all, some people say that this firehouse is haunted.
Haunted?
That's right. Chairs that rock by themselves, doors that open and close on their own. You guys aren't scared, are you?
No.
All right. You're okay with me anyway. Come on in.
We're not afraid of ghosts. This is no ordinary fire station. It was built for people and horses. In 1904, they didn't have fire engines. They had horses. And they didn't have Halloween decorations like this. When you shine the purple light on the paints,
Whoa.
some of them glow.
That's really cool.
It is. Look how bright it's glowing.
But I don't understand. It's a dark light, but the paint's really bright.
It is a dark light, but it's actually putting off a lot of light, but it's just light that we can't see.
You mean invisible light?
Exactly, invisible light. And this is special paint also. This is called fluorescent paint. And fluorescent paint changes a lot of the light that we can't see into visible light.
So the purple bulb gives off some light that we can see and some that we can't. The invisible light is called ultraviolet. And some of the paints are special too. They're fluorescent. Fluorescent things change some of the ultraviolet light into visible light, so they glow.
How do you know there's invisible light if you can't see it?
Well, you can try the experiment where they actually discovered invisible light. Have you guys ever used a prism?
Yes.
And what does a prism do?
It shows a rainbow.
Exactly. Now, if you were to shine a rainbow onto a thermometer, what color do you think would be the hottest?
Red, green, orange.
What color do you think is the hottest? When you shine sunlight through a prism, it makes a rainbow. A long time ago, someone took the temperature of a rainbow and discovered invisible light.
So how do you take the temperature of a rainbow? We use this kind of thermometer. When you put it on something warm, it changes. You can see a warm hand.
Whoa!
Cool. So fast. It's changing all the red. And outside the red.
How does it do that?
Is there light there? We did another trial and the same thing happened. The invisible light below red is called infrared. A rainbow has some colors that we can see and some that we can't. The invisible infrared, or IR, made the thermometer get warm. And the invisible ultraviolet, or UV, made the paints glow. We use vision to sense visible light, but another sense can detect IR. When we stand in the sun, we get warm. We can feel infrared light.
Thermometers and touch can sense infrared light. But there's a better way to detect invisible light now. The fire department has a camera that can see infrared.
Pretty cool. Did you see? Look at that.
It has like a light.
That's right. It's warmer than the surrounding things.
So everything that's warmer, like...
Shows up lighter. Absolutely.
Now we can see the world in infrared.
So what is light anyway? Light is a kind of energy that travels as a wave. This wave is a wiggling solid. And this is a wiggling liquid. This is the sun, where most of our light comes from. And this is the earth, where we get the light from the sun. But between the sun and the earth, there's no matter. No solids, no liquids, no gases. So light isn't wiggling matter. So what wiggles?
What wiggles? What wiggles?
What wiggles?
It's like this. When you rub a balloon on your hair, something happens to the balloon. The balloon changes. Now the balloon has a force that makes hair stick to it. And that's what wiggles in a light wave, the invisible force. Molecules have this force around them, so when molecules wiggle, they can give off light.
Hey, you just made some light.
I didn't see any light.
Well, how fast do you think you could wiggle that balloon?
A lot.
A lot? Well, in order to make light that you could actually see, you would have to wiggle that balloon about a quadrillion times a second.
That's a lot.
That is a lot.
We can't wiggle a whole balloon fast enough to make light that we can see. But individual molecules can give off visible light if you make them wiggle quickly enough.
In order to see the light from matter, you need to make the molecules wiggle really, really quickly.
How do you make molecules wiggle that fast?
It's easy. You heat them up.
We can show this with a stove. But don't try this at home. It's dangerous. When you turn a stove on low, the burner gets warm. The molecules in the burner wiggle faster and faster and give off some light. But they don't wiggle quickly enough for us to see the light. This is what the stove looks like with the IR camera. Can you guess which burner is on? A warm burner only gives off invisible infrared light. Let's try this again, but turn the burner on high to get it really hot. This makes the molecules wiggle even faster, and we can see the light.
The left one's very dark, but the right one's pretty white.
These two cups look the same, but only the right one has hot water. Firefighters can use the IR camera to find hot spots in buildings. And what about us? We're warm. Our molecules wiggle, and we give off invisible light. Our bodies are infrared light bulbs. Firefighters can use the IR camera to find people in the dark.
Now take a look at the faucet, guys. Right here. What's it look like on the camera?
looks the same.
All right, now keep watching for just a second.
Oh! The wire's like dark. Oh!
Keep watching.
Whoa! Awesome! There's a ghost!
Now that's not a ghost. This is a haunted fire station, but what you really see is my reflection in that door. See? Can you see me moving my arm?
Yeah.
You see the reflection of my heat in that door. Pretty cool, huh?
Yeah.
We thought we found the ghost, but it was just his reflection off the fire truck. The paint on the fire truck is an infrared mirror. Some things have really different properties with invisible light. For example, this plastic looks transparent. Visible light goes through it. But look what it does to UV. It makes a UV shadow, and the paints stop glowing. It's opaque to ultraviolet. And we wear sunglasses to protect our eyes. Suntan lotions and some sunglasses are opaque to UV. And what about glass? Glass is transparent to visible light. But it's opaque to infrared. A plastic garbage bag? Infrared light goes right through it. And smoke is normally opaque. But firefighters can use a special camera to see through smoke.
Really the top.
No ghosts in the bathroom.
Oh, it's really dark.
No ghosts in the bedroom.
Yeah, it's dark. Ghost footprints.
Wow.
Ghost.
Those aren't ghost footprints. Let me show you. Remember how I told you that this camera shows heat?
Yeah.
You see the heat signature from my foot?
Yeah.
Now when I move my foot, you'll still see the heat from where my foot has been. Watch this.
Cool.
That's not a ghost footprint. Actually, it's my footprint.
Our body heat leaves infrared footprints.
Hey guys, I got something special in this locker. You want to meet him?
Yeah.
Haha, that's Bones. This is our mascot.
Hi.
Say, hi, Bones.
Wow. Very weird hand you have.
I think we found the ghost.
How does an IR camera see invisible light? To find out, we looked on the internet. This is the company that made the IR camera.
Beginning in 1972, the company moved its production facilities from Sausalito, California to Cynthiana, Kentucky.
Cynthiana?
Isn't that close to here?
Yeah, I think so. In Harrison County, as a matter of fact. This is the E.D. Bullard Company, where the IR camera was made. Oh, there's some. Yeah. But that one's melted.
And that side's melted.
It still works. and they make them tough.
Hey guys, welcome to Bullard. Can I help you out with anything?
Yeah, we saw one of these cameras at a fire station and we were wondering how they work.
You have come to the right place. We happen to make these things. So let's get you guys signed in as guests. We'll get you some badges, and then we'll go back to the lab and we'll talk about how the cameras work.
Okay, cool.
This is where it all happens. The people here decide what the camera should do, how to make it work, how to build it in the factory, and a bunch of other stuff. And they're also experts at how they work.
Inside this device is this. This is really the heart of the thermal imager.
Tiny.
It is small. The rest of this is really built about protecting this. But in its easiest form, this works just like your eye does. Very similar. At the front we have a lens. The lens is used to focus the heat energy, just like the lens at the front of your eye focuses light. On the inside, we have a detector. That detector is actually made up of 80,000 tiny little switches. All of those little switches can see and measure heat. And so the way they respond to heat is how the imager makes a picture for the firefighter to use, in exactly the same way that your eye uses light. You have a lens at the front. It focuses light on the back of the eye, and on the back of the eye are millions of cells that can interpret the light and make a picture. We're doing the exact same thing, but we're doing it with heat. Heat is actually a form of light. It's just a form of light that you and I can't see.
So the sensor in the camera is just like our eyes. It just senses different colors of the rainbow. They also test the cameras to make sure they last.
So if you're going to make products for firefighters, you have to make products that can take the type of environment that the firefighter will work in. In this device here, what we test for is heat exposure. So we take a product, we put it on the inside of the oven, we turn this panel on. This panel will get to 500 degrees Fahrenheit. When it's to temperature, you simply rotate the panel down, and that will bake the imager at 500 degrees. The imager has to work in those types of temperatures before we can give it to a firefighter and tell them to rely on it.
Surprisingly, they also test the imagers in the cold.
Everybody knows that a house fire is hot and that firefighters work in heat, but what we forget sometimes is there are firefighters in cold places like Alaska, and the imager has to be able to work in those types of temperatures. The camera has to be able to be exposed to water without having any effect on the way the camera operates, even to the point of taking the battery out and changing the battery underwater.
It still works. They also test it in a giant hamster cage.
Well, it just continually tumbles the imager.
But the drop test is the most fun. It's still together. They also make the cameras here in Cynthiana. But we can't show you. It's a secret. IR cameras are a lot of fun, too.
3, 4, 5, 6, 7, 8, 9, 10.
After all, hide and seek is much easier when you have state-of-the-art search and rescue equipment. And why wait for snow to make angels? When you rub against the ground, friction makes the carpet warmer. But you can only see the angels with the special camera. Thanks, Bullard.
So what did you guys think about the thermal imager or the IR camera today?
That was pretty cool.
It was pretty cool, wasn't it? What would you say if I told you that I have a flashlight that produces invisible light?
Why would you want something like that?
It sounds silly, doesn't it? But I bet it's something that you use just about every day.
That's not a flashlight. That's remote control.
It is a remote control, but it's also a flashlight that produces invisible light, and I can prove it to you. All I need is this digital camera here. Do you see anything coming out the end here?
No.
From this little bulb? No? But if we look through this digital camera, you'll be able to see the light that it produces. Just watch this. Watch the screen here.
Whoa, there's a light.
There is a light. There's always light. It's just light that you can't see without the digital camera. Pretty neat, huh?
Yeah.
When you press the buttons, the infrared light bulb blinks. That's how the TV knows what to do. You can try this at home. But it's time for us to go home. We have to get our costumes ready for tonight. And the firefighters have a job to do. Maybe they'll use the IR camera to find hot spots in a building.
Maybe they'll use it to see through smoke.
Or find someone in the dark.
Maybe they'll use the IR camera to save someone's life.